dear organizers, dear participants, good afternoon. Currently, the volcanic field of the Westeifel is maybe the best outcropped area in the world. It means, and for this, it allowed a very good insight into the interior of the volcano, not the landscape, really in the interior, we will see. Furthermore, the Eifel has unusually high proportion of mass. The Ulmen Maar is the most prominent example and also the youngest volcano of the Westeifel, and as simultaneously the youngest volcano of Central Europe. Thus, we concentrate our highlights on the formation of mass in the still active volcanic area of the Eifel. My co-authors are Volker Lorenz, an expert of Maar diatreme volcanoes, there, and Andreas Schüller, the managing director of the UNESCO Nature and Geopark Vulkan Eifel. For him, the staff member Sabine Kummer is here. Yeah. The world map shows volcanic areas with different amounts of mass. The bigger the point, the higher the amount of mass is. We worked very intensively with an Ukrinerek Maar in Alaska, which were formed 1977, and with the Mars in the Lamongan area east of Java. The Eifel area, located between the Rhine and Mosel River here, is located in the Rhenish Massif. It's this and this one, consisting mainly of folded lower Devonian sediments and of the Variscan orogeny. A small part of Triassic sediments also occur here. In the Tertiary and in the Pleistocene time, during about 800,000 years, the area of the Eifel has been strongly eroded. In the uplifted area, you could find 600 strongly eroded tertiary volcanoes and young volcanoes, several hundred of young volcanoes formed here in the East Eifel and in the West Eifel. Recently, by intensive mapping the active quarries in the West Eifel, we could increase the numbers of volcanoes up to 280 eruptive centers. Of these, 167 are scoria cones, 83 are maars, 16 are tuff rings, 10 are scoria rings, and 4 are strongly eroded maars. That is, only the diatreme has been preserved. Here, a little bit separated, it's Ulmen Maar located. North of the Ulmen Maar, the very old Jungfernweiher is located. The drilling group of Sirocco could give results about the climatic development of the Eifel area till in the interglacial time, Eemian interglacial time. Maars were formed by explosive contact between magma and groundwater. As you can see here in the experiments run of Szymanowski and Lorenz. The explosion at the depths of hundreds of meters and the subsequent phreatomagmatic eruption creates a collapsed structure, like here at the beginning of the Auchinleck East Maar, and like a sinkhole in the karst area. With a number of eruptions, an explosion, the crater widens and the diatreme deepens. So let's jump now to the field and have a look to the active quarries. Just now, with Michael Ocht from the State University in Arizona, we observed a new Maar in the Otten quarry, 70 meters in diameter, just north of Gmünder and Weinfeldmar. Here is the location. And its northern rim, during the growth of the Mars, large block of Devonian rocks slide into the crater and then into the diatreme. On the southern rim, the youngest tephra lie on the crater discordance within the crater. The 9 meters thick tephra wall overlie a glacial soil below this ground. It means this Maar is the youngest, represent the youngest eruption of the Downer Mars. This is quite new result now. Here you can see the Löhlei Maar exposed by mining activity of basalts. This is a Maar with a lava lake. The lava was pumped from a scoria cone at the northern part into the Maar crater. At the northeastern entrance area, you can see the out and in dipping Maar tephra and also the crater discordances. The Oberstadtfeld-Maar exposed 5 eruptive centers in a large Maar crater. At the beginning, a scoria cone formed, followed by the activity of these tuff vents. One of these you can see here. The youngest tuff vent exposed crater discordances and intrusive veins of basalt which transferred near the surface into pyroclastic fragments. It is quite an other mechanism as the mechanism in the depths. The Eselsberg volcano consists of 2 Maars and several eruptive centers on its northern part. They have formed simultaneously in a very thick Strombolian phreatomagmatic sequence. It's below these and here also. After this big sequence, phreatomagmatic inwardly dipping tuffs located on the northern part of the crater of the Eselsberg. There are outcropped some channels, primary channels, formed by base surges, the small one here and the big one, and by secondary mud channels formed by heavy rain on the steeply dipping tephra sequence. The Geesmar represents example of low sustainable tephra mining activity here. The owner of the pit, Mr. Cordel, produced a substrate that used for greening of sports fields. The slow mining activity allows at the same time the use of these crater tephra and the diatreme tephra for water emergency supply, as you can see here in the hydrological modeling. Here, this is a permeable bed. Sorry for this. So now let's go to the scientific tradition. It was the high school teacher, Steininger, who transferred the expression Maar for the lake to an entire volcano, Maar. This was the first. Foundation was the first who produced and created the first volcanological map of the West Eifel together with Mitscherlich in the scale 1 to 80,000. The next mapping was carried out by Zieper and Rahm, followed by the mineralogical and paleontological investigation of Frechen and Straka. The next remapping of the West Eifel was carried out by Mertes and Büchel by their doctoral thesis supervised by Schminke and Lorenz. At the middle of the 17th, it was a working group of Negendank who start with the intensive drilling of the Maar Lake sediments with spectacular results in relation to the development of the climatic development in the Pleistocene time. Lorenz, back from USA, worked out a conceptual model for the formation of Mars. 2000, the first International Maar Conference was held in the city of Down, followed by different conferences in different countries. The first phase of seismic investigation took in this time. The second seismic array start now at this time. To have also a look of the recent investigation, I would like to emphasize to the doctoral thesis of Anne Sturm from Heidelberg University. She is carried out age dating of xenolites. Now let's conclude the main arguments why the Ulmen Maar is a good example for IOGS for the heritage sites. The first are the superb, excellent outcrops, but at the same time, the obligation for the preservation of these sites. The second is the results in relation to the climatic development of this area. Here you see a flood event. The third is to discuss with a very good outgroups to discuss really the phreatomagmatic processes again. And the third, to think about where and when the next volcano will erupt. Vielen Dank für Ihre Aufmerksamkeit. It is our students who are trained in the World Heritage Sites. That is what matters. Thank you very much.
Thank you.